Introduction to Relations and Functions. In this lesson, we're going to learn the difference between step builder notation and interval notation, how to find domain and range of relations, how to classify things as functions, and how to find table values on a graphing calculator. So let's start off with step builder notation and interval notation. Step builder, we saw this earlier, is this notation right there. So all this means is x, the line here is such that x is greater than -2. So it's all the x values where x is greater than -2. If you want that write down interval notation, I would like to draw a number line for that, sure. So we're saying that, hey, at -2, where all the numbers bigger than that. So in interval notation, since I can't be -2, we put a parenthesis there at -2, and we go all the way into arrow, infinity. So in interval notation, I'll just be from -2 to infinity. Right, all the values from -2 on. Keep in mind, when you can't be the number, it's a parenthesis, and when you can be the number, it's a bracket. So like if you think about number lines, this will be a bracket at -2 to infinity. Infinity sign is always a parenthesis because you can never reach infinity. It's not an actual number. That's what this stuff here says. So key things, right? Open circle, parenthesis, close circle, bracket. Arrows are always infinity, which are always parentheses because you can never reach them. And you can see here all the different notations of it. So if you're greater than A, you're from A to infinity. And then here's a graph version of it. If you're between A and B, but you can't be A and B, it's parentheses on both sides. So it looks like this. If you're less than B, so you're starting on the left-hand side, right? So if you're at B, but you're less than it, so it'll be -infinity all the way to B. And again, -infinity, just like infinity, you can't be it. When you see an equal to signs, that means you can be the value. So that's when we start getting the brackets. And then it's all the same from here and here. So you look at those. This one's an OR statement. You see that they're not connected. So you're less than A or you're greater than B. And you just write that in the step builder notation. And if you can be any number, -infinity, positive infinity, you just write x to the row number. It can be anything. Keep in mind, real caution, right? And when you write an interval notation like A to B, it looks like a point. If I write from 1 to 5, when we're talking about interval notation, that's all the values from 1 to 5, not the point 1 to 5. We're in the exact same thing. It's all about context. So when you mean interval, we're saying all the values from 1 to 5. When you mean a point, you mean a point 1 to 5. Right here they'll say, you can refer to them separately. So let's do a couple examples. Using interval notation, write each set, then graph it on number line. I actually kind of go backwards. I'll graph on number line first, and I'll write it in interval notation. So here's my number line. Here is 0. It cannot be 0, open circle, and I'm less than 0, right? Less than. It kind of points you in the right direction. If you just put like a little thing there, looks like an arrow. The pen is too thick for me to do that. If I zoom in really nice, look at it, it's kind of like this, right? So it kind of points you in the direction. I want to go to the left. All the numbers less than 0, this way. Come on, there we go. So there's my number line. So all I would do is, okay, arrow is -infinity on that side, and then I go all the way to 0. So there's my interval notation, there's my number line. Same thing over here. So this is saying x such that x is all the values between -5 and 4, but -4 is inclusive. So -4 will have a closed circle, and -5 have an open circle. Remember, when you're counting backwards, -4, -5, -6 goes this way, and you're all the values in between it. If I want to make that an interval notation, I'm just going to go parenthesis, bracket, and then -5 then -4. So that's how you write an interval notation. Now we're going to go backwards. Using the x variable, write each interval notation as a step builder notation. So this is saying 3 to infinity. If you want to draw the number line, I just know this is, that's everything from 3 on, right? If we're doing the number line, looks like this. So we're going to go the set x such that x is bigger than 3. All the values bigger than 3. My curly brackets kind of suck. Anyway, notice I cannot. It's a parenthesis, so it's an open circle. No line. Over here, all we're doing is we're between 0 and 8. So set it up. Curly brackets. I cannot draw, such that x is between 0, and 8. So x is all the values between 0 and 8. There we go. Again, both sides have parentheses, so no line underneath. And there we go. That's how you write it in set builder notation. Next, relations, domains, and range. So a relation can be any set of ordered pairs. That's the whole point of this problem right here. We're giving you an application problem. The atmospheric carbon dioxide concentrations in all these years: 1958, 1975, 1990, 2017. Just keeps going up. Not great for our Earth. Anyway, we can make this a relation. In 1958, the relation is 315. And this year, it's 335. In 1990, 355. 217, 405. Right? So it's a relation between these two pairs of values. That's all it is. Relation is a set of ordered pairs. All a relation is. Now, when we talk about a relation, we could break up to domain and range. No, I didn't change the number. The domain is all the x values, or the input values. So my domain of our relation from above would be the years. 1958, 1975, 1990, and 2017. The range will be all the y values, or the output values. So my range will be 315, 335, 355, and 405. So that's your domain and range. Domain and range are just literally the domain's the x values or input values. Range is what you get out, or the y values. In general, when we write it this way, this is set notation. You want to write it from lowest to highest. In this case, it kind of went that way anyway, but that's the way you would do it. So that's my domain and range. It's just the x values and the y values. We can also do as a graph. So if I give you a graph, y equals 2x, right? So how do you graph that by hand? Well, anytime you want to graph something by hand, all you have to do is make a table. That's what they did here. So you just make a little xy table. You pick some points, doesn't really matter. Standards like -2, -1, 0, 1, 2. And then all we're going to do is I'm going to substitute these x values into my equation. So you substitute -2 into the x, you get 2 times -2 is -4. Same thing, substitute -1 in, you get -2. And you keep on doing that, you get the exact same values they got right here. These values here will be my domain. My range will be the values we get out, which will be the y values, which are right here. -4, -2, 0, 2, and 4. And then you get this ordered pair here. So again, domain will be all the x values, range will be all the y values, just plot them in. And then if you want, you can connect them. So that's how you graph a line. So we talked about how to find a relation if it's a graph up there. If it's a table of values, right here. If it's an equation, you just make a table of values. You just plug them in yourself. Well, if it's a mapping diagram, that's what this guy is. Sorry. This is a mapping diagram. So this basically just gives you all the x values and all the y values, all the domain values and all the range values. So this is just an ordered pair just done in a different way. So this lets you know, hey, -2 goes to 5. So if I made an ordered pair out of this, an xy chart out of this, it goes, okay, -2 goes to 5, 1 goes to 2, and 3 goes to -1. Or if you want, I guess you can make an ordered pair. Right, I can make this -2, 5, 1, 2, 3, -1. So that's what a mapping diagram is, right? These are all different ways of doing the same thing. You can make it a graph, you can make it a table, you can make it a set of ordered pairs. They all do the same thing. They all connect. So it's an example. Let's sketch this graph by hand, not use the calculator. So again, hopefully most people know how to graph this already, but we're going to assume like we don't know how to do it. So if I want to graph this, all I have to do is make a chart. Like we talked about before, industry standards typically -2, -1, 0, 1, 2. And then all we have to do is substitute these values in for my x value right here, and then whatever I get here will be my y value, my output, my range. So I'm going to do each one real quick. So negative 2 squared. Keep in mind this negative 2 here, I'm plugging into this, substituting into this. That's inside the parentheses. When I square this first, I get 4, but there's still a negative on the outside. Negative 2 squared is 4, but there's a negative on the outside, so I get negative 4. Same thing with negative 1, plug in negative 1. That becomes 1, but there's still a negative on the outside, so negative 1. Substitute in 0, you just get 0. Substitute in 1. Well, that gets me 1, there's a negative on the outside. And the same thing when I substitute in 2. I get 4, but there's a negative on the outside. So I get these values, right? Again, this would be my domain. This would be my range. And all I have to do to graph it, just plot my points. So 1, 2, 3, I don't need to go that far. 1, 2, 3, 4. 1, 2, 3, 4. Negative 2, negative 4, so my x, my y, so negative 2, and then negative 4. Negative 1, negative 1. 0, 0. 1, 1, 1, negative 1, and then 2, negative 4. I'll connect them. You get something like that. That's how you sketch a graph by hand. Next, let's talk about what a function is. So, there's a difference between a function and relation. Right? Relation can be anything. Any two things, that's a relation. This is a relation. As long as you're comparing two things, you're relating two things, it's a relation. Now, some relations are called functions. And that's when every x value must correspond to exactly one y value. AKA, all x values have to be unique. Right, so all the x values have to be different. I don't care about the y values. They can all be the same for all I care about. If you want something to be a function, all the x values have to be different. So each x value must correspond to exactly one y value. That just means all the x values have to be different. You can't have two of the same x values. So in the function right here, 1, 6, 2, 6, 3, 6, all my x values are different because that's all I care about. This is a function. I don't care, all the y's are the same, doesn't matter. On this one, 0, 5, 1, 3, 0, 4, these two match. So this is not a function. So that's how you tell if something's a function or not. If I give you a set of ordered pairs. Next step, what if I give you a graph? So what if I just give you, that's what the blue line here is for. If I give you a graph, I tell if it's a function or not. Well, we have something called the vertical line test. All you do is draw vertical lines. And if you only hit every point at least, if you only hit every point once, a max one time, then it passes. So this passes the vertical line test, which means it's a function. So when you draw vertical lines, you go and hit everything once at most. If you hit it more than once, like this line right here, hits it here and here, then you failed. And it's not a function. So that's how you tell. If you go back up to our graph from earlier, right, if I draw vertical lines, this would pass the vertical line test. Only hit the graph once at each spot. Right, so now we know how to find if it's a function or not based on if I give you a set of points, just check out x values, make sure they're all different. And if I give you a graph, you do the vertical line test, it's essentially doing the same thing. You just want to make sure that you only hit every x value once. That's why if you only hit it once, it passes. If you hit an x value more than once, like we did here, it fails. So let's do some more examples. Determine the domain and range of each function and tell of each relation, and then tell whether the relation is a function. Assume the calculator graph extended definitely table includes only the point shown. That will come up at the very end here. So this is the first example. Remember, these are essentially just points. It's the point 112, 113, 114, and 115. So this is not a function. I should have done the domain and range first, like they asked. So it's not a function. All the x's are exactly the same. Generally, you do domain, you only write a number down once. So if like it repeats, you only write the one time. So I have all ones, so my domain is just 1. My range would be all the y values here. So 12, 13, 14, 15. I know we already said it's not a function because all the x values are exactly the same. The next one, domain. So my domain here is a graph. So you want to go furthest left here. My furthest left is -4. My furthest right is 4. So that's my domain. My domain is my x values. But now are we going to count this as a bracket or a parenthesis? Now, since it is a line, that means you can be the value. So this is actually a bracket. We're going to go from -4 all the way to 4. So interval notation, -4 to 4. Generally, it's my favorite interval notation. You could do set builder if you want, x such that x is between -4 and 4. But I prefer interval notation personally. The range will be the y values. Let's do some different color. So my lowest would be -3, same idea. That would be a bracket, that's as far as you could go. You actually can be that -3, and then you go all the way up until you hit 3. So my range would be -3 to 3. So there's my domain, my range. Is it a function, yes or no? It is not. It does not pass a vertical line test. If I draw a vertical line, hit it, I'm going to hit a point, hit x value twice. So not a function again. Next one, same idea. Let's do domain and range first. So my domain, again, domains are x values. So what's the first left? What's the first right? My first left is 2. It's a bad 2. There we go. My furthest right is an arrow. Remember what I said before? Arrows are infinity. So we're going to go from here all the way to arrow, which is an infinity sign. So from 2 to infinity. And again, infinity is always a parenthesis. You can never reach it. It goes on forever. It's not a number. Parentheses. This is a solid bracket because it is a value could be. Right? It's a closed circle. If that was an open circle, it would be a parenthesis, but it's a closed circle. It's a bracket. Okay, how about my range? Range is a little trickier for most people. Range, I always say you want to go low to high. Domain, you want to go left to right. So what's my lowest? If you go from the bottom like up, what's my lowest? It's right here. Now again, the y value, not the x value, it's 0. That's the lowest it gets, right there, 0. And then, highest it gets is right here, but it's an arrow, so it keeps on going on forever. So it's right there, it's infinity. So I'm going from 0 to infinity, because again, arrow. So from 0 to infinity. And again, 0 is a closed circle because it is a bracket because of the closed circle right there. So that's my domain, my range. Is it a function? Does it pass vertical line test? In this case, yes, we do. Function. Next one's based on a graph, like you put this in your calculator. I want to find the min range of this on your calculator. So this is what the thing I mentioned earlier said. Assume that a calculator graph extends indefinitely. So all that means is, at the end of your graph here, there's little arrows. So that's what they want you to assume. So domain and range. So my domain, left to right. Now again, my farthest left I see is like you might say -2, but that's an arrow. And arrows are infinity. In this case, we're going to the left, so it's negative infinity. It just keeps on going down. My farthest right, you might think it's 2, but it's an arrow, so it keeps on going. So infinity. Negative infinity to infinity. And if you want to do set builder, it would be x such that x is a real number. So it's any number you want to be, any real number. My range actually means the exact same thing. Lowest down here, but that's an arrow, so negative infinity. Highest is up here, but that's an arrow, so positive infinity. Set builder would be the same thing, just with the y. I'm not sure if we just set builder with the y yet. It would be the same idea, just with the y. Y is a real number. Because remember, range is y, domain is x. So if you're doing a sepal, you want to make sure that that also applies. Is it a function, yes or no? It would pass the vertical line test. So yes, function. Next one's a mapping value. So here's the thing that maps. Now remember, you always see this as points if you want, right? So like this is like the point 110. And then we have 215, but we also have 219. There's a problem there. And we have 319. And we have 527. Right? So 1 goes to 10, 2 goes to 15, and 2 goes to 19. That's a problem. This makes it not a function. We're going to have two of the same x's, which is a no-go for function. So it's already not a function. My domain would be the x values, which are just essentially these values here. So my domains would be 1, 2, 3, 5. And my range will be the y values, which are these values here. Again, you only write each one once. It's like the way you see it. You know it gets used twice, you only write them once. You just want to know what the values are in the range, not how many times they get used in the range. So there we go. Tables and graphing calculators. So we're going to show you. I'm going to show you a convenient way to find different values that fit this equation here, or any equation. So an equation such as y equals 9x minus 5 describes the function. So one way you can find out order pairs that correspond to this function is by substituting them in. So you could go like, we made a table, right? 0, 1, 2, 3, all the way to 6. You can plug in 0 into the function, you get negative 5. Plug in 1, 2, 3, and you get all these values here. And you can make a table like we did earlier by hand. Or you can use a calculator. I'll bring my calculator into the thing here. Turn it on. So first thing, since I want to find this function here, I'm going to go to my y equals and type in that function. 9x, here's my x value, my variable equation, what I should say, minus 5. Hit enter. Now, if you hit graph, that's stuff we did earlier, it'll graph it for you. But I want to find a table. So the way you do that is you go to second table right here. And then it has a table. The same one you see right there, right? It has all the values for you. When I plugged in 0, I got negative 5. When I got plugged in 1, I get 4. Now, let's talk about some other things. So you just keep on going. You could zoom up, zoom down. You could change the way this table looks. That's what this is talking about. If you go to table setup, you can see right here, F2. I go second table set. It lets you figure out where you want to start the table. So if I want to start the table at 10, hit enter. I go to my table. Now my table starts at 10. Right? The next thing down here, it's what you want to count by. This is the change in the table. So right now it counts by 1. You can see like we have here 0, 1, 2, 3, 4, 5. But if I make this 5, I hit graph, so I hit enter. When I go to my table, it's going to go 10, 15, 20. It's going to count by 5s. So that's how you can play with your table. In general, general start is 0 and 1. That's when I tell you to make a new equation, they just have that. Independent, dependent variable. So that's something I skipped earlier. Independent variable in an equation is always it's a one that's like inside the equation. So like in here, this is my independent variable. This is the thing you're substituting in for, right? I'm plugging 0, 2, 4, 6 into my x. That makes it the independent variable. The dependent variable kind of depends. It's the answer you get, someone that depends on this guy. So that's my y is generally your dependent variable. X is your independent variable. So when you put auto, it just knows that when you plug it in. So dependent variable is probably the easier one to find. That's the one that's by itself because it kind of depends on the other guy. The independent variable is the one you tend to plug stuff into. So that's how you read tables from a graph. Okay, last thing we're going to talk about is function notation. So in general, y is equal to f of x. They're the same thing, right? So you should know how to read this. When f of x reads, when you see this is f of x. The notation is called function notation. So when you have an equation like this, y equals 9x minus 5, you could also write it as the function f of x equals 9x minus 5. And if you want to figure out what a value is, like when x equals, this is all done kind of funky, sorry. So you have this, and you want to figure out what happens when x equals 2. So you're like, yeah, I'm just going to substitute that in. I'm going to get 9 times 2 minus 5, which gets me 18 minus 5, which is 13. Right, so my answer is 13. But you can also write that as f of 2 equals 13. Remember that this means f of 2 equals 13. Another way to write in that is the point. When I plugged in 2, I got 13. So these are equivalent. As you can see here, lower pair 2, 13, also known as f of 2 equals 13. A little word of caution here, right? You can read this later. The symbol f of x does not indicate f times x, right? This is f of x, not f times x. That would be a different thing. So let's finish this off here with find f of x at the indicated value. So all I want to know here is what's f of x at x equals 1. So what is f of 1? So all we do is substitute this 1 in for everywhere I see an x. So 2 times 1 squared minus 1 plus 3. Kind of like that. Now remember, when you do this, you always do the square first order of operations. So I'm going to square this first, which gets me 1. So now it's 2 times 1, which is 2, minus 1 plus 3. That is 1 plus 3, which is 4. So f of 1 equals 4. Or if you want, it's a 0.14. Number 64, same idea with this. So again, I want to figure out what f of negative 8 is. So all we do is we're going to substitute the negative 8 in for my x. So like this. So I get the cube root of negative 8 squared. Negative 8 squared is 64. So I get the cube root of 64. Cube root of 64 is just 4. Same answer. So f of negative 8 equals 4. Okay, let's take a little step worse now. For f of x, find a f of a, b f of b plus 1, and then c f of x, f of 3x. Okay, so we're going to do f of a, f of b plus 1, and then c we're going to do f of 3x. Now, for me, the key to this problem is all right here. What is your f of x saying, right? They're saying f of blank equals 2 times blank minus 5. That's all this means. Whatever I plug into this space here for x, I plug into the space here for x. That's all that's going on. So my first one here, f of a just means plug in a for x. Substitute my x with my a. So you get this. Right, and inside that space, we're going to plug in a. So I just get 2a minus 5. That's all I get. When you substitute a in for x, you just plug it into the space there and you get 2 times a minus 5. Same thing for the next one. Right? F of x in this case says 2 times something minus 5. So 2 times something minus 5. The something in this case is b plus 1. So like that. And all we're going to do is simplify this. So distribute 2b plus 2 minus 5 equals 2b minus 3. That's what f of b plus 1 is. F of 3x, same concept, right? It's 2 times something minus 5. In this case here, my something is 3x. Simplify it, you get 6x minus 5. And there's nothing else you can do. Those are your answers. So all we do, it's all about understanding what function notation means. Right, f of x equals 2x minus 5. That really just means f of whatever equals 2 times whatever minus 5. The same thing goes for this one. So my a here, we're going to do f of, A, they wants to do f of a. B, they wants to do f of b plus 1. And then C, they want to do f of 3x. So again, for me, the key is all about right here. What is f of blank? It's 2 times blank plus 4. Right? Whatever is into my x here goes into my x here. So for the first one, it's easy. F of a is this 2 times a squared plus 4. Nothing really you can do with that. The answer is just 2a squared plus 4. The next one, right, it's 2 times something squared plus 4. My something in this case is b plus 1. Now this one kind of sucks. Actually, let me erase it. I'm going to give myself more room to write it. So 2 times something squared plus 1. And we're plugging in b plus 1. Okay, the reason this one sucks is because b plus 1 everybody gets wrong. It's not b squared plus 1. When you square something, you multiply by itself. It's b plus 1 times b plus 1. That's what happens when you square b plus 1. You multiply by itself. And then you distribute. So I'm have a 2 on the outside, right, from this guy. Then b plus 1 squared, so b plus 1 times b plus 1, you're going to get b squared plus b plus b, right, multiply b times both of these, and multiply the 1 by both of these. Plus 1, and then there's a plus 1 at the outside. Right, so it's 2 from right there. B plus 1 times b plus 1, so b, so distribute, I get b squared plus b, then b plus 1, and then there's a plus 1 at the very end. And then you just simplify this, so I'm going to get 2 times b squared plus 2b plus 1 plus 1. And actually simplify it some more, I can distribute this 2b, just 2 into everything. 2b squared plus 4b plus 1, plus 2, sorry, plus 1. So I get 2b squared plus 4b plus 3. Like that. And that's my answer for this one, right? Again, I cannot stress enough, when you square something, you multiply by itself. You don't just square it. Well, when it's a plus sign specifically, when it's a binomial specifically, or a trinomial, anything, you multiply by itself. F of 3x, I'm going to do this really fast, right? F of x is 2 times something squared plus 1. In this case, we're plugging in 3x. Now, in this one, since there's no plus, you can just square it, but 3x times, you can also just do 3x times 3x, which would be 9x squared. Right? Again, the problem here is that the binomial, there's a plus sign in between. That changes the whole game. Right? Anytime it's broken up like this, the binomial or higher, you have to multiply by itself. If it's a monomial, you can just distribute. So I get this, which gets me 18x squared plus 1. Okay, last thing. Use the graph of y equals f of x to find each value, f of negative 2, f of 0, f of 1, and f of 4. So we're going to do f of negative 2, f of 0, f of 1, and f of 4. Okay, let me make my thing lighter. There we go. Okay, so remember the way this works? Remember the thing you plug in is your x value. The thing you get out is your y value. That's how these functions work. So my domain, my range, right? My input, my output. So we're plugging in the x value. So this is my x value saying, what's the y value at this x value? So I have a graph here. So where's x equal negative 2 at? Right here. So my x equals negative 2. What's the y value? Now you might say, looks at what, negative 3? But it's actually an open circle, so there's no value there. So no solution. No values, I'll put the empty set. There's no value at negative 2. So when x is negative 2, I get no value. Remember, another way to think about this, this is just, f of x just means the y value. So all it wants to know, what's the y value at negative 2? That's all it's saying. Like the next one, right? So my x value is at 0. When x equals 0, what's the y value? So here's 0. What's the y value? Negative 2. Right? Basically it's saying at the point 0, my graph is 0, negative 2. That's like the point there. Right? Is that a point on the graph? Yes, it is. 0, negative 2 is a point on that graph. Right? F of 1, what happens when x equals 1? Here's my x, here's 1. My graph is at 0. And then finally, f of 4, what happens when x equals 4? It's at 2. And again, these also work as a point. That's like the point 4, 2. Right? When x is 4, it's the y value. And that's the lesson.